For this video, I'd encourage you to grab the atomic structure worksheets that are available as resource guides. This is just going to give us some practice with calculating kind of tables of subatomic particles. There's actually two worksheets that are there. If you page down, there's a second one that's a little bit harder. So let's stick to the first handout. And what you should be able to see is that we've got kind of these, 6 different categories that we have to fill out, and the sheet should begin with lithium-7. So I just wanted to do a couple of these with you so that you feel a little bit more comfortable, and then I'll kind of show you how to do the second worksheet. This is a really common thing at the beginning of a chemistry class to kind of learn how to do this stuff. So feel free to kind of go forwards and backwards. If there's anything that confuses you, just send me a message. Okay, well, first of all, of course, we need the handy dandy best cheat sheet in the universe, the periodic table, so make sure you have that. This is basically impossible without that. So we've got a lithium-7, right? There is a place where you can talk about the element name or the symbol. There's really 3 different ways to represent elements. We've got the one that is written out as lithium-7. We could have also named this thing in all of its glory. We could have written the name and symbol like that, right? The other way that you can see it is maybe I leave the 3 off, right? Because we know that the atomic number is always optional. And so there's a couple of different ways that we could show that. I guess technically there's another way where I could just write Li-7, but I'm not going to worry about that. So the important thing that you're able to fill out is this table right here. So if I have a lithium, right, we look at the periodic table, it better have a certain number of protons. It turns out that proton number is 3, right? It has to have 3 protons or it's not a lithium. All right, what else can we fill out? Well, at least for this week, right, there is no charge on any elements. So we can just automatically say, well, there must be 3 electrons there as well. Other things that we can fill out, we could fill out the atomic number, right? Make sure that you can define that. The atomic number is just the number of protons. So we're doing pretty well. For the mass number, that is going to correspond to the 7, right? And so we've got a mass number of 7. The number of neutrons, if you remember how to calculate that, that is always the number of protons plus the number of neutrons. So this is like super complex algebra, right? We got to have 3 plus something equaling 7. Well, 3 plus, I think, 4, right? We know that that particular isotope of lithium has to have 4 neutrons in it. Another thing, which isn't in this particular worksheet, is this atomic mass, right? Well, it turns out that if you just had a random sample of lithium, I think its atomic mass is around 6.94 or something like that, atomic mass units. Turns out that the most common isotope of lithium is in fact lithium-7. Okay, so that wasn't asked, but that's just kind of another really typical thing that some jerk will ask you someday. All right, this next one is we're going to do essentially the same thing. It's just that the numbers are going to get a little bit bigger. So at the very beginning here, we've got Ag. So what we should do is kind of have a treasure hunt for silver, I guess, on the periodic table. And you will find that Ag strangely corresponds to silver. I should mention a lot of these guys are based on, the element symbols are based on the old Latin names of some of these elements. We don't have to talk about that too much. But so turns out silver is Ag. So we're just going to call this silver 110, right? And of course, in this position, we also could have put silver with 110 superscripted. I couldn't remember how many protons were in a silver, so I just looked at it on my periodic table. And so this is hopefully what I looked up. I've already forgotten it. I better check. Yep, that's what it is. Okay, so two different ways that I could write out that name and symbol. Keep in mind that 47, because it's a silver and we know how many protons have to be in there. You can also leave that off. It's up to you. Number of protons is 47. Since it's uncharged, we know that there are 47 electrons, and we also know the atomic number is 47. Number of neutrons, keep in mind, we know the mass is 110. So if we do some really quick math, I think that ends up being 63. But once again, please check me just in case I'm having an instance of board brain. Not too bad. The next type of calculation is going to be kind of a variation on this theme. Instead of maybe giving just the element symbol and the mass, instead what we're going to see is that we're kind of given various combinations of all these other numbers. And so that'll be the very next segment of video. All right, on that second worksheet, it seems like there's information that's, there's too little information to answer the question. But if you take your time with these, you can actually realize there's a whole bunch that you do know, again, because of that periodic table. Well, we know that we have a beryllium, right? So let's start with our treasure hunt and find beryllium. And the only item of information that's given to us is that we've got 4 neutrons, right? Well, it turns out that beryllium, I believe, yes it is, the 4th element, right? And so we know automatically, because we looked at our periodic table, that we've got 4 protons. This thing is uncharged. So we know we have 4 electrons, and we automatically know the atomic number is also 4. For the atomic mass, that again is just straight off of the periodic table. So let's see. I'll just round it. I've got 9.012 AMU plus a whole bunch of other decimal points. And what we can do now is probably figure out the mass number, because we remember that mass is only due to protons and neutrons. So I've got 4 protons, I've got 4 neutrons. That means my mass number is 8. So a really common kind of question to ask that kind of builds on this information is this the most common isotope of beryllium? And the answer is most likely not, right? Because you'll notice that the atomic mass units of the atomic mass are around 9, and this one has a mass number of 8. That's not to say it can't exist. It's just not the most common isotope of this particular element. So I hope that makes sense. Here's the second example from that worksheet. So instead of giving us the number of neutrons, what they've given us is the mass number of 12 and the fact that this thing is a nitrogen. So once again, once you're given an element name, it's really helpful to just look up on the periodic table. And it turns out that nitrogen must have 7 protons. If I've got a mass number of 12, well, that means I must have 5 neutrons, right? Because that has to account for the missing mass. This week, that number of protons is going to be equal to the number of electrons. The atomic number for this guy is going to be 7. And then the mass, I can't remember the exact value, but it's like blah, 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 AMU. It's like right around 14. You should look that up. Maybe I'll do that just to be complete here. I guess there was just a 7 that I left off there. So 14.007 AMU. Again, really common question. Is this the most common isotope of nitrogen? And the answer would be no, because those values, that rounded doesn't equal this. So we come to the third and final example that I'll go through with you here. By the way, I'm going to be posting answers to all of these worksheets just so that you can kind of check your work. Most likely I'll post those tomorrow. So looks like this one's really missing a bunch of information, but it does tell us the number of protons. So it turns out that we know exactly what the element is. We're going to call this thing a chlorine. So chlorine, 17 protons, 18 neutrons. the number of protons is going to match the number of, the number of electrons is going to match the number of protons. Your mass number, if you added both of these neutrons and protons up, would be 35. Your atomic number is the same as your protons. And then the atomic mass, I think, ends up being like 35.47 blah, blah, blah AMU. So again, all the rest of these are just kind of variations on that theme. I hope it helps that we kind of went through this in excruciating detail. Talk to me on Canvas if you need any help.